notice that the definition of phi for polynomials have let us reach the exponential, and the exponential have reached us sine and cosine. We can derive the sine and the cosine also from the polynomial series of Taylor expansion series of the sine x and the cosine of x. Now we will introduce a new operator which is called the shift operator. It is it is called E, and it is when E is applied to a n, it gives us a of n plus 1. Take a look at this example to know what the shift operator does. An equals n squared, which means if we plug the input here 0, 1, 2, 3, and 4 until 13, a of n equals 0, 1, 4, 9, 16, and so on. EAN means that if we plug in 0 to EAN, we instead plug E of 0 plus 1, which is E of 1. When we plug 0, it's as if we plug 1, so we get 1. If we plug n equals 1 here, E of A1 equals A2, which is means A2 equals n squared, 2 squared equal 4, and so on. When we plug in 2, A2 equals A3, which is 3 squared. 3 squared is 9, so we get 9, but notice that 1 is for the input 0, 4 is for the input 1, and so on. You will see that this sequence is shifted to the left to get this sequence. 169 is here, 124 and 44 is here, and so on. This is like we shift all the series by left to the left by 1. If we introduce e square will be e squared multiplied to an will be e multiplied to e of an is an plus 1, and e of an equals to a of n plus 2, which means we get the second, not the next input, not the next output, but we get the next output, which means shifting each of those series by 2, and so on. We'll see that these operators uh, works like this. We will introduce a product rule that is similar to the product rule in continuous calculus. The delta of un multiplied by v of n. U of n is a series, v of n is a series. If we multiply each term one by one, we will get the new series un vn. We we need to know the difference operator when it is applied to both of these. Un vn will be un plus 1 vn plus 1 minus un vn by definition of the difference. We can add un plus 1 vn and subtract un plus 1 vn. We don't no, we haven't done anything. We have added one term and subtract it. When we can change the position of it a little bit, we will take this term and this term in this bracket here, and this term and this term in this bracket here. We will notice that we can take un plus 1 as a common factor, and we will get delta vn. And here we can take vn as a common factor, and we will get vn multiplied by delta un. Notice that un plus 1 can be written as eun. So delta of un vn equals to eun multiplied by delta vn, plus Vn multiplied by delta Un. We know that the multiplication is can be written in reverse. So we have delta Un Vn equals delta Vn Un. So we can write the same formula here before, but replacing U with V and V with U. Un will be Vn, delta Vn will be delta Un, Vn will be Un, delta Un will be delta Vn. This can be seen graphically. Well, this can be seen graphically as here. Delta Un Vn, we have here the first function which represents an area. Un multiplied by Vn, that is why we represent it as a rectangle of area Un Vn. The increase of Un can be seen here. Sorry. The increase of Un can be seen here, which is delta Un. The increase in Vn can be seen here. We can get the change in the function as these two areas, the first rectangle and the second rectangle. This rectangle can be thought of as Un delta Vn, Un delta Vn, and this second rectangle can be thought of the overall height is Vn plus 1, which is EVn multiplied by delta Un. Likewise, we can say also we can take the first rectangle to be fully, and the second rectangle will get shorter, and introduce the change as Un plus 1, which is EUN multiplied by delta Vn plus Vn multiplied by delta Un. Vn is here, delta Un here, Un plus 1, delta Vn. This is why they are both equivalent to each other.